can just listen to some Rusty Bucket Bay in the background. I'll you on the time. Okay. Also, do I have that G going outside the box? There we go. Okay. We're going to look at something that's, yeah. I, I guess what I want to say about this is, up until now, we've been looking at graphing things, moving them left and right, moving them up and down, but they've been in this really nice form where we're actually able to do that. So if you think about something like this, it's like, cool, I can graph that because I know it's just x squared like that, and it's moved to the right ones, and now I can graph it. But why is it given to us like this? They've explicitly put it in this form where I can read it off of it and just be like, look, it's moved to the right one. But if you think of this as if it's just a regular old equation, or like an expression, like if that wasn't there, you might get a question like this and let's say expand. Like that's just a set of brackets. I can expand that. So maybe I'll do that. So if I were to expand that, then I've got. So I'm just working on that right hand side. It's a perfect square, so I can do a shortcut, but I'll use FOIL. I'll do this properly. That's the same as this, which is the same as x squared minus x plus 1, which is x squared minus 2x plus 1. Okay. Now, what's stopping somebody from giving you a question that says, here's an equation, graph it? Now, at the moment, you have no tools available to be able to graph this, but I do have the tools to be able to graph this, and they're the same thing. It's just an ability to recognize that, look, that's what I've got to be able to do, something like that. Now, I guess what I'm trying to say is there's a skill in here that involves looking at something like this and being able to read off it and being like, okay, well, I know that I can put this in this form, and that means I can graph it. Now, graphing this without any knowledge of perfect squares actually requires calculus, but we'll get there. I want to pitch to you a different idea, and it's something that we've been looking at, well, I guess last lesson. Let me use this example. Okay. Now I look at that and I say, well, look, that's just the equation of a circle. I know that, and its center is 2 and 5, and its radius is 3. So I can graph that easily. But it's given to me in this beautiful form where I can do that. A question doesn't have to do that. Let's try and expand this whole thing. I'm going to try and do it in one step. X squared minus, I'm not going to do this one step, minus 4x plus 2 plus y squared minus 2 times 5 times y, 10y. If you're not sure what I'm doing, you can just use FOIL, equals 9. Now, look, this is something that I can simplify. There's a 2 and a 25 and a 9. So if I move all that over, minus 4x plus y squared minus 10y equals, okay, so then it's 9 minus 2, which is 7, minus 25. 7 minus 25, there's not something I can do in my head. So minus 25, that's minus 18. What's the fuck, Alex? Minus, what did I say? Minus 18. Okay, what's up with someone saying graph this? Well, good luck is what I'm saying. So I guess what the theme of this lesson is turning something that looks like this into something that looks like this. Now, I guess the difficulty in this is going to be the questions where instead of it looking like this, so I can obviously just factorize this to make it look like this. But what happens when there's a plus 2 out here, and then there's a plus 2, and a plus 2, and a plus 3? Now, I cannot factorize that. I can't factorize this. I probably could with the quadratic formula, which we don't know yet, but I can't factorize that. And this, I can't factorize that either. It's got x's and y's in it. So how do I get from this to this? And how do I get from this to this? Well, that's called completing the square. So you'll notice that each of these has a square term. This just happens to have 2 of them. So let's work through this. Now, when you're completing the square, you're making a perfect square. So what I'm going to do is I'm going to create a perfect square, And if it's not already 1, so for instance, if that's a +1, I know that I can factorize that into a perfect square, but if it isn't 1, which means I've got this plus down there, there's going to be a loose term or a constant, which just means I'm going to have another term kind of sitting out here plus something, or another term like this sitting out there. So I'll explain what that means in a second. I'm going to do 2 examples where I go backwards. So let's suppose I've got 1. There's so many ways of teaching this and so many ways of thinking about this that my method might not make sense to you. So what I'm going to do is I'm going to link an AnyWoo video if you want to watch that as well, if what I say makes no sense. But it's essentially just being able to factorize something that you can't factorize. Okay, so let's start with, let's do the technical one. It's got x squared plus 10x. Okay. Oh no. I want to do that. Okay. So what I'm going to do is I'm essentially just given this part of it. So I'm given this part of it. I want to be able to add a term onto here so that I can write this. My goal is to be able to write this as x plus or minus, I don't know, plus something squared. That's the goal. The goal is to write this into a square. I'm trying to create a square or complete the square. So the goal is to have something in here. That's the goal, to put something in there. So to get there, what you do is this, and it comes from recognizing something out here. So when I had this +1 in the end here, so actually forget this exists for a second. To get this +1, which is the thing I'm trying to find, that's my goal, is to get that extra term at the end. Well, what I've actually done is, see these 2 terms in here? It's this term squared. That's how I actually get that term. That's the relationship, and it works for all of them. So this one, if I were to halve that, see I've got the same thing here twice. There's an extra step in here where I've got this halved. So if I halve that, and then, have I stuffed that up? I have stuffed that up, that's meant to be a 4. Damn it, which means that's going to be negative something else, 20. Okay, so if I halve this 2 and square it, I end up with this 4. If I halve this minus 5 and I square it, I end up with 25. So what you're actually doing to get this goal is you're going to do this. You're going to halve it, so then I've got 5, and then you're going to square it, so that I get 25. I've actually got the exact example up there. Exactly. Okay, so this is how I actually do it. I actually draw 2 arrows. This is how I work it out. So that means that this whole thing, oops. So we're going to go x squared plus 10x plus 25, and then I can factorize that into a perfect square, which is plus 5 squared. And if you can't do that, it's actually this term that ends up in the set of brackets. Now, there's a lot going on here, and it can be pretty confusing. Like, I remember completing the square when because I did advanced, but I wasn't in 5.3 class. There wasn't 5.3 class actually when I was in school. So I was in top class, was 5.2. We never actually learned completing the square. So I learned this when I was in year 11, and I remember thinking, what the hell is this? This is like the most random thing ever. But if I guess you gain a little bit of an understanding of it now, then it's going to help you next year. So essentially all you're doing is you're adding a term on the end here that's going to create a square, a perfect square. So that's exactly what this is. You're completing the square. This is exactly what it is. So in the case where I'm told, okay, can you please graph this? Let's suppose I want to graph this, and it's y equals x squared. I'm making this up. X squared plus 5x plus 10. Let's suppose I want to graph that thing. Now, I don't know how to do that. I know how to graph something that looks like this. So, and yeah, okay. So my goal is to graph this. In order to do that, I need to make it look like a square, so I can actually graph it. So what I do is I grab this term and I halve it. If I halve that, that's going to be interesting. let's go with it. Let's roll with it. 2.5. And then square it. Just 2.5 squared. This is what I make examples of 6.25. Okay. What I did over here was I added it on the end. So I'm going to do that. I'm going to. Oh, of course it's not a square. You idiot. Sorry. Okay. So I'm adding this plus 2.5. Now this part, that's going to be my square. Okay. But I've still got this plus 10 on the end over here. I've still got this plus 10 on the end. And I can't just add a number to something. Let's take it away also. So I haven't actually changed anything. I haven't changed what the graph is or anything. Okay. Now this thing I can turn into. So if I factorize this, it's actually this. Am I stupid or what? 6.25. I think I'm stupid. 6.25. I've made a terrible example. Now, 10 minus 6.25 in my head, 3.75. Okay. Alright, so what have I done? Let's recap for a second. This is overwhelming the decimals. I've got something I can't graph. I want to be able to turn it into something I can graph by having something brackets and then plus something. That's going to tell me how far left or right. That's going to tell me how far up and down. At the moment, I have no idea what it looks like. So what I do is I get this term, I halve it, I square it, and I add it on. I can't just add it on. I have to take it away as well, so I'm not changing anything. Those two cancel and end up with what I started with. And what I can do is this thing that I've added helps me factorize it into a perfect square. And it's this term that ends up in the brackets. Obviously, you won't be able to see that with this because I've got a decimal. It's probably the worst example I've ever come up with, but sorry. And then there's this loose term on the end. So now I can graph that because that is to the left, 2.5, and that is up 3.75, and it's a parabola. Now, the whole point of this lesson wasn't to be able to graph a parabola, it was actually to be able to graph a circle. So this is the last example I'm going to do, and it's going to look like this. X squared plus 4x minus 6 plus y squared minus 6y plus 4 equals 0. Okay, I want to be able to graph this. Now, at the moment I have no idea what the hell this thing looks like. Well, actually I do. There's an x squared and there's a y squared. So I'm assuming it looks like a circle. So I need to be able to get it into a form that I can work with. A form that I can work with is x minus something squared. I'm not sure to write this in smaller handwriting. X minus something squared plus y minus something squared equals r squared. I need to get it in that form. Now, in order to do that, I need to be able to factorize my x values. So I need to be able to factorize this. So what I need to do is add to this a term that's going to turn this into a perfect square. So I need to write this as x squared plus 4x plus something. That's going to be my first one. And then plus y squared minus 6y plus something plus 4 equals 0. So my goal is to be able to factorize each of these. In order to do that, I need to complete the square. So complete square literally means I'm completing my term that's going to make this perfect square. Now, what I do is I halve this and I square it, 4, and that goes in there. I halve this, minus 3, and I square it, 9, and that goes in there. Now, I go x plus 2 squared plus y minus 3 squared, okay, plus 4. Now, how did I get from here to here? Well, 1, you could factorize it. 2, so like what adds to this and times to this? Well, 2 and 2. And what adds to this and times to that? Well, minus 3 and minus 3. Or you just say it's this first term goes in there, that first term goes in there. So I haven't really think about it. Now, before what I did was up here, because I added 6.25, I needed to take away 6.25. Here I've added a 4 and I've added a 9. So really, I need to take away a 4 and take away a 9. Or what you do to one side, you do to the other. So this side I've added a 4 and added a 9. So here I could add a 4 and add a 9. Add a 4, add a 9. Okay, so let me just keep rewriting this. X plus 2 squared plus y times 3 squared equals, make sure those line up. Okay, I'm going to move this 4 over, so that's going to be 4 minus 4. Cool. That's going to equal 9. Now 9 is the same as 3 squared. So now I'm able to draw my circle, and I'm going to have absolutely no room for that. Let's go over here then. A circle, it's got a center at minus 2, 3, and it's got a radius of 3. So if the center's at minus 2, 3, that's like up here, and it's got a radius of 3, then it's going to look like this potentially. That's terrible. Okay, so that radius is 3, and that point is minus 2, 3. And that's that. So the goal of this lesson is to be able to have something that isn't factorized nicely like this, and factorize it by adding a term on the end and making it factorized with maybe the loose term on the end. That's the whole point. So I hope that made some kind of sense. If it didn't, then I apologize. Maybe I'll explain it better next year, but I don't really... I like to be able to compare things to things that you know, and you know how to graph a parabola. That's not in the notes or anything, that's not in the textbook or anything, but I think it's important to be able to see that these things are made nicely for you. They don't have to be like that. They can be like this, where well, I could complete the square on this. So if I did that, I'd have x squared minus 2x, and then you halve this and square it. So halve it, square it, that's a plus 1. And I've got a plus 3, then I've got a minus 1 to counteract that. So then this whole term turns into x, so I halved it minus 1 squared, and then this part on here is just plus 2. So I end up with what I started with. So that's what completing the square is. It's turning something that looks kind of gross, and I say to myself, can I factorize that? Well, no, I can't. So what I will do is complete the square. So I wish this was taught, and it is next year, but I wish it was taught more towards when we're factorizing, because this is essentially a factorization technique. Because you look at this and you're like, can I factorize that? No. So when you're asked to graph something like this, you generally go through a mental checklist and you say to yourself, okay, can I factorize this quickly? So that means this minus 2 add to something and 3 times to something. No, I can't think of the two numbers, so I can't put it in this. Is it perfect square? No. Okay, so then you go, all right, well, I'm going to have to use a quadratic formula, which is something we'll do next topic. And then, that would be how you find x-intercepts or whatever. But there's a step before that, and it's, can I complete the square? And technically you can complete the square on anything, which is kind of what I've shown with this terrible example here. But you complete the square and then you'd be able to draw it properly. But completing the square can sometimes take a little while. Not if you're fast at it, but now I'm just rambling. That'll do, I think.